right, Lily, let's get you caught up to where the rest of the class is. Great to see you today. You are looking healthy. It's nice to see a smile, and Brianna was happy to see you as well. So that was good that we worked that out. So the next lesson in the book is right after page 34. It's a supplemental section, so it has no page number, but it starts off with direct substitution or synthetic substitution. And we're going to look at this process, and it's used in a couple of different ways. And we have three purposes for using it. It's pretty quick and effective method once you get the hang of it, and can be used instead of long division in the case that we are dividing by a linear factor or a linear polynomial, anything to the first degree. Anything higher than that, when we're dividing, we have to use the long division method. So this is a kind of a shortcut, going with the synthetic method when we have a linear dividing by. So the first example right on the first page is when we use it for substitution. So if I were to traditionally do this problem, we would fill in all the x values with a 2, and then using a calculator or simplifying, 2 to the 4th is 16 times 2 is 32, 2 to the 3rd is 8 times 4 is 32, 2 squared is 4, and 1. 32 minus 32 is 0, 0 plus 4 is 4, 4 plus 1 gives me 5. What this synthetic substitution method allows me to do is work with the coefficient of each term. So my coefficient of the first term is 2 because it's 2x to the 4th. And then I have negative 4 because it's negative 4x to the 3rd. And then I have 1 because it's 1x squared. I have a 0 because I have no x's, and I have a constant of 1. So it's really important that we include these zeros when we are going down with the degrees of the exponent, as they are important in the division process. So I want to know what the value of this when x is 2. I'm going to put my 2 on the outside. And here's the process. The first number comes right down. I'm then going to multiply by the number I'm dividing by. So 2 times 2 is 4. I'm then going to add the two numbers together, and I get 0. I'm then going to multiply by the 2, and I get 0. I'm then going to add and get 1. Multiply, 2, add, get 2, multiply, and get 4, add, and I get 5. And whatever number you end up with right here is essentially the same as putting 2 in for x. We're evaluating that function. So if you remember when we plugged it in and did all the math out, we got 5. When I do this process, I get 5. Now it seems like a lot to remember at the first, but as we go along, it picks up. So we've got 3 examples to look at. So on the next page, example number 1. So again, I start with my box and my coefficients. 5x cubed, 2x squared, negative 6x, and 8. And I want to evaluate it for when x equals 3. So I'm going to bring down the 5. I'm going to multiply 5 times 3. That gets me 15. And then I'm going to add. And then I'm going to multiply 17 times 3, which is 51. And then I'm going to add. And then I'm going to multiply 45 times 3, which is 135. That should be -8, sorry. And when I add 135 and -8, I get 127. That is my answer. So if I put 3 in here, here, and here, and did all the math out, I'd get 127. Or the synthetic substitution method gets me 127. We'll jump to the next one. Feel free to pause or go back. I'm sure you have as we've been going along. So -2x to the 4th. I have 0x cubed, 10x squared, 1x, and 4 is my constant. This time I want to know when x is -1. Bring down that first number. Multiply. Add. Multiply. Add. Multiply. Add. Multiply. And I get a final answer of 11. And the third one on the page, feel free to pause if you want to try it by yourself. And then I'll go through the answer. All right, given adequate time to pause, coming back, I've got 3x to the 5th, -1x to the 4th, 0x cubed, 0x squared, -5x, and a constant of 10. So again, whatever number is here is going to be my answer. And I want to know what's the value of the function when x is -2. First number comes down. Multiply, add. Multiply, add. Multiply, add. Multiply, add. Multiply, add to get your final answer of -92. So I'm going to break this into 3 separate videos for each part so you can watch. The process is the same throughout, but there's 3 different uses. So try to avoid some confusion. I'll break it down into 3 parts. So this will be the end of part 1, evaluating a polynomial for a given number using the synthetic substitution process. When we start part 2, we'll look at the synthetic division. You'll see on the next page some examples, and we'll go through those, but the steps are also listed out in numerical form 1 through 9, and that's what we'll start with the next video, part 2.